Hi guys, welcome to CMA solution page. In this video, we will watch operation planning sums, illustration number 5, question and its solution. Okay, let's go to the concept. A department works on 8 hours shift, 250 days a year and has the usage data of a machine as given below. The products are X, Y, Z, annual demand units are given and the processing time also given. Determine the number of machines structured. In this sum, we have to calculate the number of machines structured. Okay, let's go to the solution. First, apply the product and annual demand. We have to apply the sample time in hours. Okay. But to arrive at the answer, we have to apply the formula workload per year divided by production capacity per machine. Okay. In order to calculate workload per year, we have to find out the processing time. Processing time is nothing but 300 units into 4. That is annual demand into processing time will be the processing time needed. Okay. So we have to multiply 300 into 4 and the 200 is the answer. 400 into 6, 2400. 500 into 3, 1500. Then we have to total that. 1200, 2400, 1500. The total will be 5100. 5100 will be the hours. Okay, we have to apply this in the workload per year. Then we have to divide it the production capacity per machine. Production capacity per machine is arrived from 8 into 250. Okay, 8 is nothing but the 8 hours of the work and 250 days. So by multiplying 8 into 250, we have the answer 2000 hours. So divided 5100 and 2000, we get 2.55 machines. Round of this 3 will be the answer. So the number of machines required is 3 machines. In illustration number 6, a steel plant has a design capacity of 50,000 tons of steel per day, effective capacity of 40,000 tons of steel per day, and an actual output of 36,000 tons of steel per day. Compute the efficiency of the plant and its utilization. So in this sum, we have to calculate the efficiency of the plant and the utilizations. Okay. Here we have the formula for this. The formula is efficiency of the plant is equal to actual output divided by effective capacity. Utilization is equal to actual output divided by design capacity. We have to memorize this formula. Okay. In questions, we already have actual output and the design capacity, effective capacity. So we have to apply that. 36,000 divided by 40,000 into 100. The answer will be in the percentage because we have to multiply 100. So the answer will be in the percentage. So next we have to apply 36,000 divided by 50,000. These are already present in the question. So we have to apply it and into 100. Multiply by 100. So the answer will be 72 percentage. Okay. So this is a simple sum. We have to note it. In illustration number 7, a firm has 4 work centers A, B, C, D in series with individual capacities in units per day shown in the figure below. Raw materials A, B, C, D and its work center capacity. Actual output are also given. So they ask to identify the bottleneck centers. The bottleneck center is identified by which center have minimum capacity will be the bottleneck center. So see this. The lowest is in the work center C. So we take this 340 as the minimum capacity. So hence work center C is the bottleneck center. Okay. Second question. What is the system capacity? System capacity is the maximum units that are possible to produce in the system as a whole. So we have to find out the maximum that is minimum capacity with the maximum output. Okay. So in this we have analyzed it. Okay. We have 340. So this is the minimum capacity with the maximum units. So we should take this. So the answer will be the work center C, 340 units. Then we have to move to the third question. What is the system efficiency? System efficiency, we have the formula. Actual output divided by system capacity, like previous sum. So we have to apply that actual output divided by system capacity in this sum. Okay, the answer will be the 300 divided by 340. 300 is the actual output and 340 minimum. 340 is the minimum capacity. So system efficiency, we should take the system capacity as the minimum capacity of the work centers. So this is the minimum capacity. So we have to put the 340 and divide it. In order to arrive the answer at the percentage, we have to multiply it in the 100. So 300 divided by 340 into 100, the answer will be the 88.23%. So this is the answer. Okay. Illustration number 8. A manager has to decide about the number of machines to be purchased. He has three options, that is purchasing 1 or 2 or 3 machines. The data are given below. Number of machines, annual fixed cost, corresponding range of output. Variable costs are also given, 20 rupees per unit, revenue is 50 rupees per unit. Determine the break-even point for each range. If projected demand is between 600 and 650 units, how many machines should the manager purchase? Okay, we have to find the break-even point first. In order to find break-even point, we have to apply one formula. Okay, that is, the formula is BEP, total revenue is equal to fixed cost plus total variable cost. Total revenue, we have to separate the total revenue and the total variable cost. So by separating this, we have the answer. We have to put per unit into quantity is equal to fixed cost. Fixed cost plus variable cost per unit into quantity. So we have to put the fixed cost as the fixed cost only. We should not separate this because it is not changeable. So we have to separate the total revenue and the total variable cost. Okay, by comparing those, we have to separate the quantity into revenue minus variable cost is equal to fixed cost. Then we have to put the move the revenue minus variable cost to the fixed cost side. So the formula will be the quantity is equal to fixed cost divided by revenue minus variable cost. In this way, we have to apply those amounts. Okay, the amounts will be in the question. That is, we have already have the annual fixed cost and the variable cost revenue. By applying those in that formula, we have the answers. Okay, note that variable cost and the revenue and the fixed cost only. For quantity 1, that is for using only one machine, we have to apply 12,000 divided by 50 minus 20. And for quantity 2 machines, 15,000 divided by 50 minus 20. And for 3 machines, quantity 3, 21,000 divided by 50 minus 20. The answers will be the 400 units, 500 units, 700 units. These are the outputs. So we have to compare this. Okay. For the first question, BEP sales, we have to find it the BEP sales like this. Okay. Then we have to move to the second question. Projected demand is between 600 and 650 units. We have to compare this values. Okay. These units with the we have to compare these units with the projected demand. Okay. The break-even point for single machine is 400 units, right? This would not be a feasible solution because it would be applied to the 0 to 300 units only. So we should not take that quantity 1 units for the 600 to 650 units. Okay. So moving on to quantity 3. If we take 3 machines, we have 700 units as the output. So this would be not suitable to the 600 to 650 units. Okay, if we take quantity 2, that is 2 machines, we have 500 units. This would be suitable because it is more suitable to 600 to 650 units only. So we have to take the quantity 2, that is 2 machines only. So the answer will be the quantity 2 machines. So subscribe our video and support our video. Keep going. Bye bye.